Today we're going to be looking at intersections of hyperbolas in either an ellipse or another hyperbola or a line or something of either sort. And we're also going to be looking at taking a hyperbola from general form into standard form by completing the square. So the first one we're going to look at for intersections is the intersection of this hyperbola. And we know it's a hyperbola because that minus sign and we have the squared terms, and a line. Nothing down here is squared, so this is just a line. Because my first equation has square terms and my second equation only has linear terms, we cannot do elimination. We can only use substitution. So since this x and this y are not squared, we have to do substitution. So that means we're going to put it in x equals or y equals. So first we're going to get this one into x equals by adding 3y to both sides, 3y minus 3. So the first thing we do is get x equals or y equals. And so we use substitution if not all terms are squared. This is all x and y terms are not squared. Okay, so now we're going to substitute this in to your top equation. We're going to substitute that in for x. So step 2 is substitute. So here we're going to have 3y minus 3 squared minus 3y squared equals 9. We need to FOIL out this 3y minus 3. Okay, so step 3 is we're going to FOIL. So we're going to have 9y squared. Then here we have a minus 9y. And then another minus 9y for my inside, so 2 minus 9y's would be minus 18y, and then negative 3 times negative 3 would be plus 9, minus 3y squared equals 9. Step 4 is to set equal to 0. So we're going to combine like terms as well. 9y squared minus 3y squared is 6y squared minus 18y. And then if we subtract the 9 over from this side to set it equal to 0, those 9's cancel out, so then we're just left with equals 0. Step 5 would be to factor, if appropriate. Okay, in this problem we still have a square term, so we're going to have to factor. We always look for something in common first. If you notice, both of these divide by 6. They also both have a y term. So since we're trying to get 2 linear y terms, we're going to factor out that y as well. So we're going to take out a 6y. If I divide 6y squared by 6y, because that's what I'm factoring out, I'll be left with y. If I divide negative 18y by 6y, I'm left with negative 3, because 18 divided by 6 is 3, and y divided by y is just 1, so the y's cancel out, equal to 0. We don't have any square terms left, so this is factored. So we're going to set each factor equal to 0. 6y equals 0, y minus 3 equals 0 in order to get our solutions. Here, if we divide both sides by 6, we get y to equal 0. If we add 3, we get y to equal 3. So again, we're looking at intersection points. So these are telling me the y values of my coordinates. So one coordinate has a y value of 0, the other has a y value of 3. To get the x values, we're going to plug into this equation. So we have x equals 3y minus 3. So 3, we'll start with the 0. 3 times 0 minus 3 would be 3 times 0 is 0, minus 3 is negative 3. So when y is 0, x is negative 3. We're going to do the same thing the other way around. So we're going to have 3, and now we're going to plug in 3 for my y, minus 3. 3 times 3 is 9. 9 minus 3 is 6. This would be the coordinate 6, 3. And so these are our 2 intersection points. Another one we're going to try here is elimination. So elimination we're going to use if all x's and y's are squared. Okay, so here are both x's, x is squared, y is squared, x is squared, y is squared. Since all terms are squared on this left-hand side, we can use elimination. In order to do elimination, let's go back here, we're going to add solve, and 7 would be plug in, just to finish off our steps. So on elimination, the first thing we want to do is multiply one or both equations. So x or y has same number with a different sign. So here, if we notice, we have a 1x squared and a 2x squared. Here we have a negative 1y squared and a positive 2y squared. Because my y's already have different signs, I'm going to go to eliminate my y's. So this one's negative, this one's positive. So now all this one needs is a 2 in front of it, so that way they're the same number with different signs. So I'm going to multiply everything on top times 2. So that'll give me 2x squared minus 2y squared equals 40. Nothing changes in the bottom, so we'll just rewrite it as 2x squared plus 2y squared equals 60. Now we need to add our equations together. So 2x squared and 2x squared is 4x squared. Negative 2y squared and 2y squared is 0, so they eliminate. And that'll equal 100. So step 2 was to add equations. Step 3 is to solve. We're going to put a note here in just a second. So we need to solve for x, so we divide by 4. X squared equals 25. Now we're going to take the square root. Big thing you have to remember, when you take the square root of both sides, you get plus or minus. So our note is going to be don't forget plus or minus. Anytime you take a square root, you need to have a plus or minus. So when we go to write my solutions, we know my x values are positive 5, and I also have an x value of negative 5. Last step is to plug in, because we need to get our y value. It doesn't matter which equation you use. I'm going to use the top one because it has less numbers in it. So if we plug in positive 5, we're going to have 5 squared minus y squared equals 20. So 25 minus y squared equals 20. We subtract 25. We have negative y squared equals negative 5. So positive y squared will equal positive 5. And y equals plus or minus the square root of 5. So we ended up getting two answers. When I plugged in positive 5, I get positive square root of 5 and negative square root of 5. So here we're going to have 5 square root of 5, but now we need to add another point that's 5 negative square root of 5. And I want you to write out each point on its own. I don't want you to put the plus or minus in there. Write out each point on its own. Now we technically need to plug in negative 5 and do the same thing, but I'm going to show you what happens. If we plug in negative 5 to the same equation, when we do negative 5 squared, we get a positive value, so we get positive 25. And now if you notice, these two lines are the exact same. So a number squared, a positive number squared and a negative number squared will be the same thing. So we know we're going to end up getting y equals plus or minus square root of 5 as well. So we'll have 5 square root of 5 and 5 negative square root of 5. And those will be our solutions. So here we have 4 intersection points, and if you look at it, we have a hyperbola because we have the minus in there, and an ellipse, so we have the plus in there. So it's more likely they might intersect more because we have our hyperbola with an ellipse, and so you can see where those 4 intersection points might be. Finally, we're going to write our equation in standard form. This is where we use complete the square. So these would be a complete different set of directions. These are completely different types of problems. These first two were intersection problems. Here is right in standard form. We're going to do that by completing the square. So here it just wants you to put this into standard form. It'll probably ask you to label the vertices and the foci as well. It starts off the exact same way it did with circles and ellipses. We're going to group our x's. So we'll have x squared minus 14x minus 25y squared plus 100y. So group x's, group y's, and move that constant equals 76. Just like we did in ellipses, we're going to pull out a common factor. The x's don't have anything in front. It's a positive x squared, so we can leave it as this. So we'll have x squared minus 14x. And when we go ahead and factor things out or check for factors, that's where we want to add our blank. Here we've got a negative 25 in front of our y squared. So we need to factor out the negative 25. That's the only difference between the ellipse and hyperbola. As a hyperbola, you're going to have at least one negative term that you need to factor out, or you will always have one negative term you have to factor out. So we have to factor out that negative 25 because you have to have a positive square term inside. That has to be positive y squared. If I take a negative 25, so if I divide positive 100 by negative 25, it's going to leave you with negative 4y. Also, another big area you can make a mistake is forgetting to take the negative out of that middle term as well. So you're dividing it by that whole constant. Equals 76, and we need to remember to add in our blanks. Here there was no factor out front, so we just have a blank for my x's. But here we have a negative 25 outside of my y, so you can either do plus negative 25 times blank, or you could have just done minus 25 times blank. Either way is fine. Get our blanks is half of this squared. Half of 14 is 7, squared is 49. Half of 4 is 2, squared is 4. Okay, so then we want to go through and factor this. So we've got x minus 7 squared minus 25, y squared minus 4y plus 4. We'll factor 2y minus 2 squared. On this side, we want to add up all of these terms, so you've got to keep in mind you've got to multiply this negative 25 times 4, which is negative 100. Add that to your 76 and 49. When you do that, you end up with 25. Divide everybody by 25, and you end up with x minus 7 squared over 25 minus y minus 2 squared over 1 equals 1. There's your equation in standard form. Remember, it's got to be a positive term and then minus your negative term, or minus this other term. If you happen to have a negative number over here, when you divide by your negative, oftentimes your terms are going to switch. So if you have a one that's negative, that one always has to come second, the positive one first. We'll look at some more of those in class. Always good to label your center, vertices, and foci. Our center is at 7, 2. Our vertices, because x lead, are going to go left and right. They're going to go left and right 5. So if we go left 5, we'll have the point 2, 2, because we're going to subtract 5 from 7. If we go right, we're going to add 5 to 7, which would be 12, 2. Our foci, again, because x leads, are going to change my x value. So we'll have 7 plus or minus the square root of something, comma 2. We always find that by adding our denominators. So c squared equals 25 plus 1, which is 26. So this will be the square root of 26. And that will be your final answer where you have all of those points listed out.